Alright, so today we're going to talk about chapter 2.1, which is all about classifying matter. And matter is defined as anything that has mass and takes up space. Matter can be classified into different categories based on its composition, or what it's made up of. These categories include pure substances, elements, compounds, mixtures, and then within mixtures we have solutions, suspensions, and colloids. So let's talk about what each of those means. A pure substance is matter that always has the same composition. So it doesn't matter how small you cut it up, they're always the same. An example of this is salt or sugar. So salt is sodium chloride. It's made of sodium and chloride in a fixed ratio, and it doesn't matter if I have one piece of salt or a billion pieces of salt, it's going to have the same properties either way. Every sample of a given substance has the same properties because the substance has a fixed, uniform composition. So between that 1 grain of salt and the billion grains of salt, they're all exactly the same. They have a uniform makeup. Now, pure substances have two different categories. The first one is an element, and an element is a substance that cannot be broken down into a simpler substance. What this means is if you have an element and you break it in half, and then in half again, and then in half again, and all the way down, eventually you'll just get to a single atom of that element. But you will never change it or break it down into something else. Examples of this are copper, helium, and calcium, along with all of the other about 100 elements on the periodic table. Here, you can see elemental copper after it has been removed from copper ore, and here is an example of calcium in one of its forms. An element has a fixed composition because it contains only one type of atom. What that means is if you split an element into the individual atoms, each atom would be exactly the same. And what that means is each atom has the same number of protons. And when we talk about elements in the periodic table more later this year, we'll talk about why the number of protons matters. Now, there are just over 100 known elements in the periodic table. Some of them occur naturally and some of them are man-made. But on the table, each element has its own symbol. For example, the symbol for gold is AU. And it's AU because it's based on its Latin name, not its English name. This is true for a lot of elements. So when you look at the periodic table and I ask you to find, let's say, tin, that doesn't mean you're looking for Ti or Tn. In fact, it means you're looking for Sn. So sometimes the abbreviations or the symbols for elements won't always make sense to you, but they're usually based on their Latin names. A compound is the other kind of pure substance. And a compound is a substance made from two or more simpler substances that can be broken down. So elements cannot be broken down into different things, but compounds can. Examples of compounds are water and silicon dioxide. So you know that the chemical symbol for water is H2O. What that means is there are always 2 hydrogens for 1 oxygen, but if we put enough energy into water, we can actually break this up into just hydrogen and just oxygen. We can separate them, which is what makes this a compound. Now, on the other hand, there are mixtures. And a mixture is a blend of 2 or more substances that do not chemically combine. They stay separate. A good example of a mixture that is easy to recognize is mixed nuts. You can see there are peanuts and cashews and almonds and Brazil nuts, and they're all mixed together, but they do not combine to form a new kind of nut. Another example is sand, and a third example that you might not be aware of is steel. And the properties of a mixture can vary because the composition of a mixture is not fixed. So if we go back to our mixed nuts example, we could have 2 samples of mixed nuts, and one of them has way more peanuts than the other. They're still considered the same mixture of mixed nuts, but they have different properties because it really depends on how many nuts of each kind you have. Now, when we talk about mixtures, there are 2 different types. The first type is called heterogeneous. And that means parts of the mixture are noticeably different from each other. So if you look at this picture that's coming into view right now, this is a close-up picture of sand. And you can tell looking at the sand that some of the pieces are white, some of them are light brown, some are dark brown, and some are black. This is a mixture where it's easy to tell that there are different things mixed into it, which is why we call it a heterogeneous mixture. On the other hand, a homogeneous mixture is one where parts of the mixture are hard to distinguish. It looks all the same. Steel is an example of a homogeneous mixture. Steel is actually made up of the elements iron, chromium, and nickel. And depending on what kind of steel you have, you could have even other elements and metals mixed in. But you can't tell that there are 3 different metals in here. It just looks like one kind, which is why we call it homogeneous. Now, there are 3 different subsections of mixtures, and this is where most people get confused. So if you need help describing these or more examples, I suggest going to Google, looking up a solution, a suspension, or a colloid to get a better idea of what each one is. The first one, a solution, occurs when a substance dissolves to form a homogeneous mixture, meaning you can't distinguish the parts. An example of this is sugar mixed into hot tea. As the sugar dissolves, you can't tell it's there. The sugar and water are mixed together. So it is a mixture, but you can't tell it's there. So we call that a solution. A suspension, it occurs when a heterogeneous mixture separates over time. So an example of this is dust settling on a surface. If you were to just look through the air in my living room, you probably wouldn't be able to tell that there's actually dust particles mixed in with that air. But over time, that dust settles on the coffee table and it comes out, and that would be called a suspension because over time the dust and the air separate. And the last one is called a colloid, and a colloid is in between a solution and a suspension. So a colloid occurs when the particles in a homogeneous mixture are a medium size and scatter light. What that means is the particles are bigger than they would be in a solution. So they don't completely dissolve, but they do form a homogeneous mixture. But the particles are not big enough to actually separate over time. They stay mixed together. So the particles are smaller than they would be in a suspension. And an example of this is milk. If you leave a glass of pasteurized milk sitting in your fridge for a while, you won't see the milk fat separate from the water. It's all mixed together. It looks the same, so it's homogeneous and it stays together. But we can't pass light through it. The particles of fat suspended in that water are big enough that when light hits it, it comes back to us, which is why we see it as white instead of clear. Again, if you need more examples of these 3 things, please go to Google, look them up, look up examples, look at some pictures, and that should help. To summarize classifications of matter, I have this little flow chart here. So, matter, remember, is anything that has mass and takes up space, and we can classify it into pure substances and mixtures. There are 2 types of pure substances: the elements, which cannot be broken down any further, and compounds, which can be broken down into their component pieces. Mixtures are 2 or more substances mixed together, and they can either be homogeneous, meaning it looks uniform, or heterogeneous, meaning we can tell the different parts apart from each other. So that is our introduction to matter and classifying matter, and we will talk about changes in this matter in the upcoming videos.